Okay, so this is hell. Welcome to hell. this is the that's not me weeping off camera. I'm laughing. I promise. I'm not that hurt. This is the torturing machine, aka the Turing machine, and this is my implementation of it. It's a boy. It makes me hate my board. I'm tired of looking at everything. I'm tired of looking at my computer screen. I'm tired of looking at this dumb green board. I'm just tired of looking. My eyes hurt. Everything hurts. I feel flat. I don't even know how to describe that. Like, if life is soda or lemonade with the lemons it gives you, then I feel like water. I just don't. I just don't right now. They say that pain is a good teacher, and I feel like this lab was the best teacher of all time. Like, I've learned so much from all of the pain. Like, I considered myself special amongst computer scientists because I'm cheery, and I know people in the field, and they're not out like this, like they're not all up. But I think that I just hadn't been hurt before, and now like I have my Moby Dick. You know what I'm saying? Like, I have like my Goliath. I don't think that's the right example. I have my Moby Dick. This thing messed me up. So anyhow, to the board. This is my Turing machine. The first 5 switches are dedicated to the inputs of the tape reg. So to follow your example, we'll go to 1, 2, 3, 4, 5, 6. You'll see when I turn on these LEDs, or they turn on these switches, they turn on the LEDs corresponding. And we could have anything, like whatever. But I'm just going to follow your example, and we'll do something else spicy afterwards just to show it all works. This is the reset. Oh no, this is the ready check. This is the reset switch. I have a reset switch just because, well, I mean, it's in the diagram, but also it's the only way to get out of the halt state. Yeah. In state 3, we just don't do anything, and we can't get out of it unless we reset. So it's nice for testing. Anyhow, I'm sorry if I sound dead. This thing has beaten me to the ground. But so much learning. After all the bombardment and the embarrassment and the other B words that, well, embarrassment starts with an E. Whatever, I bested it. Oh god, another B word. All I want in this class is a B, so it's showing right now. All the phonetically B sounding words. There it is. Everything that could be happened to be. You feel? And I'm dying. Anyhow, I'll shut up. Sorry. This is the ready switch. This is the reset. This is the done reg. The LED 15 is the done reg. LED 14 is the state reg. And you are the Turing state. I'm sorry. And you'll see right now they're both 0. The done reg only goes high when we're in the halt state, state 3, and the Turing state only goes high after conditions are met in state 2. We're currently in state 1. So all it's doing right now, we'll go to your work, which is a lot nicer than a lot nicer in execution. We'll go through the code. It's not bad looking, it took so long. And this didn't seem like that. So all we're doing right now is just, because we're not ready, the ready switch is not flipped, so we're just going back through here. We're setting the index to 5. So in this 8-bit number, we go to 0, 1, 2, 3, 4, 5. It's the first one, the series of 1s. That's how the board's set up. And then we're so we're going to index 5. We're setting the index to 5, I'm sorry. We're setting the Turing state to 0, and we're setting the done reg to 0. Great. We go down to 1. We go down to state 2, sorry. And then we check if the Turing state equals 1. We know it doesn't equal 1, so we go down to no. And then we check if Turing state equals 0 and tape underscore reg index equals 0. So we know we're in the first one, so that's a 1, so we go to no. The index changes to index -1, which brings us to the one to the right. So we're in the second one in that series of 1s. And we're going to do that 2 more times, so we get to that last one. We're going to do it 1 more time. And then we get to that first 0. So at that first 0, we're going to go down here, because Turing state's still 0. So Turing state is 0, and tape underscore reg index, which is right now 2, so index of 2, so it's this 0. We check if it's 1-bit binary 0. It is, yes. So we're going to set. I got silent because I put my done reg in the wrong place. We'll go through the code. I thought it was a state 3 thing. It's gonna update a little later. I should no, I'm too tired. It's a very easy fix. I would just move it from here to here. So we're just pretend this goes over here. I'm sorry, I'm dying. It's taken like 4 days to get this thing to work. Like 4 full days of work, not all after like one after the other. It's just been so long. Anyhow, so we go down to here. Yes, we're gonna set that 0 to a 1. Then we're going to change the Turing state to 1, and then I did this over there. Oops. And then we're gonna move the index. Whatever. The index doesn't. I don't show the index. All I'm showing is the tape reg, the Turing state, and the done reg. So then after this, we're gonna go back up here, and we're gonna say is Turing state equal to not equal to 1, or is Turing state equal to 1? Yes. Halt. Cool. And then we'll halt, and then we'll have to reset. So let's look at that. So it's going to take, my clock updates every half second, so it's going to take a little bit to get through the cycle, but we'll turn on the ready check. So it's probably done like 1, it's probably done like 2. Oh, there it goes. Okay, I was wrong by a little bit. So you saw that this LED 14 and this LED 2 turned on. So 2 was that 0 becoming a 1, was this 0 becoming a 1, so we should have 2 zeros still. And if we look here, we have 2 zeros, that 1, and then those 3 ones that we originally started with. And then this is the done reg. He updated late because he's in state 3. Oops. And then this is the Turing state, which updated as soon as this updated because they happened at the same time in state 2. Cool. And I'll show you the code. We'll start from the... Well, we'll just go through it real quick. So state 1... all he's doing is checking. We're making sure we're staying in state 1. And state 1, all of this has already been preloaded. And reset, we actually do what happens in state 1. Cool. So if it meets all these conditions, Turing state equals 0, done reg equals 0, ready check equals 1. So it's pretty much just waiting on this. We go to state 2, and if not, we stay in state 1. In state 2, we're checking if Turing state equals 1. If it does, we're going to set the next step equal to 3. Else, so if it doesn't, the Turing state equals 0, which it does for the first 3 iterations. We're going to set, we're going to check if the index equals to 0, the tape reg index. If it does, we're going to do all the things we described earlier. We're going to set that equal to 1. We're going to set the next equal to 1. We're going to subtract the index and set the next state equal to 3. Else, which is normally what happens, we're going to set the index minus 1. I'm just going to repeat step to stage 2. So we're going to keep looking until we get that the index of tape reg that equals 0 that we can change and then ping to state 3. And then state 3, oops, has our done reg, which is the flag that I literally just have to move up to like here. That's where it should be. Again, I'm sorry, I'm just way too tired. It's like 3 o'clock in the morning. I just need to go to sleep. But it could just be up there and it'd work fine. But we just put the tape reg equals tape next, and it's just gonna stay here forever. Yeah, and that's the whole thing. This is my clock. That's everything. Yeah. All right. Thank you for your time. Sorry, this is 10 minutes. I don't know how that happened. Have a good night. Bye. Oh, sorry, this was weird too. Bye.